So this is our chart filled in, and we won 6 out of 10 times. Now, if you decide to do this, that's fine. We did this in another class, and we played a series of times, and the class total ended up being 116 out of 300 times, and that probability was 0.387. So if we use a tree diagram to calculate theoretical probabilities and what should happen, so this is how this works. The probability of getting an ace, or getting the ace game. So there's the first card is an ace. So we're looking at this. So that probability that the first card is an ace will be 2/5. The probability that the first card is a king is 3 out of 5. All right. So then from there, or the way that we would look at this is probability. The first one is an ace. Or this one, the probability, the first one is a king. Okay, so then if we want to look at the next one, the second card is an ace. Well, if the first card was an ace, we only have 1 ace left and 4 total cards left. Then if we get an ace and a king, well, if we get a king, we still have all 3 kings, but still that ace is gone, so we only have 4 total cards left. So the way we would view like this particular probability is the probability that the second card is an ace given the first card is an ace. So what that bar means when you see this right here, that means given. So given, like, you know, you're given more information, which is always going to increase your probability. And so what we do, if the first one was an ace and the second was an ace, we take our 2/5 and multiply it times the 1/4, which is 2 out of 20. And so this is the probability the first is an ace and the second is an ace. Both of those happened. So then if the first one is an ace and the second one is a king, we multiply those two probabilities, which would be 6 out of 20. So probability that we have an ace, the first is an ace and the second is a king. All right, so then the next one. If the first card we picked was a king, if the second card we pick is an ace, well, all of our aces are left. We have 2, but again, we've already drawn 1 card, so there's only 4 left. We draw a king on the first one. Well, now there's only 2 kings left, and then a total of 4 cards left. So that's the probability of picking a king on the second draw. So if we get these probabilities, we do the same thing as before. We'll do our 3/5 times 2/4, and we'll get 6 out of 20. And we'll do our 3/5 times 2/4, and that will also be 6 out of 20. All right, so the theoretical probability of winning the game. Well, look at the times that we won. You either got an ace and an ace, so ace, ace, or a king and a king. So king, king. So we're looking at those two probabilities. You could win one of 2 ways. So that was, our first one is 2 out of 20. That was one way we could win. Or, remember this is or, and is or is addition. The 6 out of 20. So we add those two probabilities, we get 8 out of 20. So there's a 40% chance of winning the game. Okay, so what is the probability the first card was a king given that the person won the game? So the way that we write this, probability that the first one is a king given, that's what that bar means, they won the game. So what we do is we divide by the number of what we know, because it's not out of like 100 anymore, 100%. It's getting it smaller, because remember, the smaller that bottom number, our denominator, is, then the bigger our probabilities be. We're given information, we know something. So the probability that we won, we just found that out. That was our 0.4. We just calculated that. Now, the probability that the first one was a king and we won, so we kind of follow this path here. Probability the first one was a king. And we won, so I'm kind of starting here. So that probability is 6 out of 20. All right, so we just do 6 over 20 divided by 0.4. So actually that's 0.3 divided by 0.4, which will give us 0.75. So just knowing that we won increases our chances. So notice those two probabilities are different. Another quick thing we want to look at, when you're setting up your probability, you want to make sure that your totals right here, all these totals in your tree add up to be 1. So they're all over 20, and we have, basically, you've got the 2, the 6, the 6, the 6, and that equals 20. And of course, 20 over 20 is going to be 1. So we're good there. So that's one way to check to make sure that you filled out your tree correctly. Okay, so on tree diagrams, or actually let's look at the general multiplication rule first, and you can pause and copy this down as you need to. So the probability of A and B means that you're going to multiply those two probabilities. You're going to multiply the probability of A times the probability of B given A. That's your conditional probability. If A and B are independent, the probability of B given A is the same as probability B. That means that knowing A doesn't affect anything. It's not going to change the probability. The example that we just did, that's dependent. So if we just do the probability of A and B, you multiply those two probabilities. Now, tree diagrams, this is what we just did. You take your first event, you do the probability that it can happen and the probability that it can't happen. So those two should add up to, 100% or 1 in that first branch there. And then given 2 more events extended beyond there, you've got the probability of event B given A, probability of event C given A, or the probability of event B given the complement of A, which is just, you subtract it from 1, and the probability of event C given A didn't happen. And again, in the end, all those probabilities should add up to 1. And you may have more than 4 branches. Just this example we used had 4 branches. And if it ever asks the probability of at least 1, you're going to do 1 minus the probability of none happening. We'll see an example of that in the Check Your Understanding. So pause the video so you can do the Check Your Understanding, try it on your own, and then I will show you the answers. So pause it right now. So here are the answers to the Check Your Understanding. So for your states, 30 out of 50 were Republican, 20 out of 50 were Democrat. And so notice that 30 and 20, they add up to 50. So then from there, you did continental U.S. and not in the continental U.S. So 29 out of 30 were in the continental U.S., 1 out of 30 was not. And then so to get each individual probability, we multiply those numbers. So the probability of randomly selected state is in the continental U.S. and went Republican. So that's how we write it out the way that we would express it. So it's not a given situation. We're just following the tree for that probability of continental U.S. and Republican. So it's like we start here, continental U.S., and there's our answer, 0.58. Now the next one is a given situation. So probability at least one of the states, this is the at least example. So the probability of at least one, remember we're going to use 1 minus the probability of none. So that's going to be, we're going to do 1 minus 0.58 because that would mean that they're not in the continental U.S., and so that's 0.42. And so we do 1 minus 0.42, and we do the 4th power because there's 4 states. So you'd be multiplying it times itself 4 times. So then we look at this one. Here's our given. The probability that a randomly selected state is not in the continental U.S. What is the probability it went Republican? So that's how we would express it. So not in the continental U.S., we add up those probabilities. So not, actually, let me do a different color here. So not in the continental U.S., not in the continental U.S. That's where the 1 over 50 plus 1 over 50 comes from. And then if we branch out from there, Republican, not continental, It's that same probability that we did before right there. I did the wrong branch. Not continental. I should have done this one right here. So 1 over 50 will be the top number. Okay, so then you just simplify those fractions. 1 over 50 divided by 2 over 50. That comes out to be a half, or 50%.